Okay, so let's do some modeling with our identities that we've been talking about in this lecture and then the previous one. In this example right here, we have a formula that talks about the amount of force that's exerted on our lower back when we bend over, okay? And they're giving us the formula, so it's not like we have to really come up with anything exciting here. They're telling us what the formula is, but then we're going to go through and do some calculations based on it. The first problem we're going to work wants me to find out what F is, or what the force is, when somebody that weighs 177 pounds and they have a degree for theta at 30 degrees. That was 30 degrees with the horizontal. So when we are given that type of a problem, we're basically just going to come in and replace these values. So I'm going to work this so that it looks like F is equal to 0.6 times W, for this case, is going to be 170, times the sine of 30 plus 90. Okay, divided by the sine of 12. So I'm going to let my calculator do these calculations for me. And when I do this, let's see if I can make this a little bigger. I'm going to take the sine of 120 and I'm going to multiply it by 170 and 0.6. So 0.6 times 170 times the sine of 120. Okay. Let me go back and make sure that I'm in the right mode here. I need to be in degree mode. They gave me theta in degrees, so I need to be in degrees here. So let's try that again. I'm going to go back up. I'm going to try that one more time. There we go. That's different. And I'm going to divide that by the sine of 12. Nope. Sorry. Divided by the sine of 12. Okay, so just plugging that into the calculator, we get the answer to be 425 if I round it to the nearest whole number. So F would be 425. So that's basically just a calculator problem. The next problem, however, asks me to show that this identity, or that this formula for F, is equal to 2.9 W cosine theta. So let me rewrite that down here so we get an idea. We're trying to show that 0.6 W times the sine of theta plus 90 divided by the sine of 12, we're asking, and we want to show that that's equal to 2.9 W cosine theta. So we're going to try to see if we can turn this left-hand side into this right-hand side over here. So working with the left-hand side, I want you to recognize that sine of theta plus 90, that's the sine of the sum of two angles. That would be the new identities that we're working on today. That would be the sum identity for sine. So I know I can do something with that portion right there. So I'm going to try to isolate just this portion by rewriting this over to the side. This would be 0.6 W divided by the sine of 12 times the sine of theta plus 90. Okay? Now I can calculate on my calculator 0.6 divided by 12. Let's see what that is. 0.6 divided by the sine of 12. Hey, that's 2.9. That's what I'm wanting to find over here, so that's looking good. So I'm going to rewrite that as 2.9 W times the sine of theta plus 90. Now I want the sine of theta plus 90 to look like the cosine of theta. I do that using the sum identity for sine, which is what we're practicing on today. So 2.9 W times. When I expand this or rewrite it using our identity, this becomes the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Okay, so let's simplify that. I know that the cosine of 90 is 0, and the sine of 90 is 1. So the sine of theta times 0 causes this portion right here to cancel or go away. So I end up with 2.9w, and then the cosine of theta times 1 is just the cosine of theta. And that's what I wanted to show. So we were able to use our sum identity for sine to show that this is indeed the way that that works. Now, I just kind of want to make a note here. Some people have asked me if they could have used the cofunction identity. This isn't the cofunction identity, right? Cofunction identities are 90 minus theta. They have a minus sign in here, so we couldn't have just used that one. That wasn't valid. Okay, and the last thing it asks me in this particular question, it's asking me for what values of theta is the function at its maximum. So what value of theta is the function at its maximum? Well, let's just think about that, because we know what a cosine function looks like. Cosine functions, don't they start up top, they go down, and they end up top. So every time I'm up at top, then I'm at a maximum. So what value of theta is the function at what value of theta is the function at a maximum? At 0. Isn't that at a maximum right here? Isn't my function at its peak right here? So when theta is 0, because remember the x-axis is theta, when theta is 0, then my maximum, when theta is 0, then my function has a maximum. So that's just one example of using modeling and our new identity. In this particular case, it was the sum identity for sine.